These chips used to have 1 million transistors, 10 million transistors, 100 million, a billion, 10 billion, 100 billion. Now they'll have 1 trillion transistors. Imagine designing 1 trillion transistor chip in a year. How complex is that? That is the complexity I was talking about to Yossi. Why Synopsys came up with this new way of re-engineering engineering in our 40th year.
Hi, everybody. Good afternoon, good evening, and good morning, wherever you are. Thank you very much for joining the Boardroom Club today to another episode. My name is Yossi Garmazi, and I'm joined also by a good friend of mine, Amado Vargas. Amado.
Hi, everyone. Thank you for joining us today.
So today we are fortunate enough to interview none other than Prith Banerjee, SVP of Innovation at Synopsys, a company that revolutionizing the future of semiconductor design and AI-driven engineering. Before that, Prith was actually the CTO of Ansys, a company that got acquired by a staggering $35 billion by none other than Synopsys. So, Prith, thank you so much for joining us today.
Thank you very much for hosting me here. I'm looking forward to the conversation.
The pleasure is all ours, Prith. So I want to start with a question a little bit about your journey, because it's a very unique one indeed. You actually spent 20 years in the academia before moving to leadership roles in household names like HP, ABB, and of course Ansys and now Synopsys. But looking back at your time at Northwestern and University of Illinois, what was the aha moment that convinced you to leave the dean office and join the corporate world?
That's a great question. When I graduated with my PhD from the University of Illinois in 1984, I had a choice at that time to either join the corporate world. I had offers from IBM Research and Bell Labs and a dozen universities. But at that time, I decided to stay back in academia, and I stayed back as a professor at the University of Illinois. And I spent 12 wonderful years moving through the ranks, became a full professor and a department head of computational science and engineering. Then moved to Northwestern University after 12 years, was a department head there for about 8 years, then became Dean of Engineering at University of Illinois, Chicago. During those years, Yossi Armando, I kind of did what academics do, supervise PhD students, write lots and lots of publications, doing fundamental research in different areas. What I found lacking was all this wonderful innovation I was trying to lead, it was not quite transferring in the world of products. So that got me thinking, and that was sort of my second phase in my career where I started 2 companies based on technologies from the university. First was Excelchip, which was based from Northwestern University, and I raised money from VCs, went all the way, built a product, sold the company to Xilinx Corporation, and started a second company, Bynachip, sold it to Quickstream Media. So that was second phase in my career where I saw the fruits of, well, how do you take an innovation from a research lab at a university and go all the way, make it into products that customers are using? And that really started the third phase in my career, the large corporate world, where I first joined Hewlett Packard in 2007, and I ran HP Labs worldwide. It was a fantastic opportunity. And then I worked, as you mentioned, as CTO at ABB, Schneider Electric, Ansys, and now Synopsys. And the experience I've gotten in these sort of 3 areas of innovation in academia, innovation in startup, is actually something I have brought to my world in leading innovation in large companies such as Synopsys.
That's incredible. And you mentioned Ansys. So, of course, Ansys got acquired, as I mentioned in the intro, for $35 billion, one of the most complex acquisitions in history, during also a complex time indeed. But how do you ensure that essentially the post-merger integration of such large-scale acquisition deliver maximum value for the shareholder?
Let me give you the thesis behind the acquisition so that your listeners can understand. Synopsys was a leading provider of electronic design automation and intellectual property in the chip design. Silicon design, it was the leader, right? But then these chips go inside complex systems like a car, right? A software-defined car or a software-defined airplane. The Boeing airplane that you fly in or the Tesla car that you drive in, they are all software-enabled and silicon design. There's a chip inside the car, but the product is actually an intelligent product. So The thesis behind the acquisition is you take the leading provider of chip design software and IP, which is Synopsys, with the leading provider of system design. Ansys is the leader in automotive, in aerospace, in energy, industrials, and healthcare, right? Every customer in those areas, they use Ansys simulation. So what if the chip company, chip software company, could be combined with the system software company? What an amazing opportunity for our customers. That was the thesis behind the 35 billion acquisition. The acquisition was announced in January of 2024, but the acquisition closed in July of 2025. It took 18 months for the acquisition because you have to go through all the regulatory approvals in all the countries and so on. But we did not stop. We started preparing for the end state, right? We started imagining what a combined solution of these two companies would be. And so when July 2025 happened, we could do the planning. We could not do any actual integration. But right after July 2025, we have started doing the integration. And so when you do this integration of these two large companies, there is what is called revenue synergy, there is sales synergy, with this functional synergy. So there's a lot of planning that went in, and we are really very far along the line. We are making significant progress. For example, in the area of, as you said, right, how does 1 + 1 become 4? So if you could just take this sort of a 6 billion in revenue from the Synopsys part, about 4 billion from the EDA and hardware business, the 2 billion from the IP business, and the 3 billion from the Ansys business, that would just be a 9-ish billion, right? But we are really making progress along the lines of we have announced that our revenue will be about 9.5 billion this year, and we are going to grow significant revenue between the joint solutions. So we have already, at our Synopsys Converge conference last month, we highlighted some of our joint solutions. For example, in the area of what is called 3D IC, three-dimensional integrated circuits, right? You put lots and lots of complex chips on top of each other. In the past, the Synopsys part could only do the chip design, but now you put multiple chips, multiple chiplets on top. We can, through the Ansys and Synopsys combination, we can do thermal simulation. We can do electromagnetic simulation of these very complex chips with 3D stacked ROMs and HBMs and so on. Something that the industry could not do before can be done today.
Simulation of the physics is definitely the future. Do you think that this new combination of the two companies gonna go beyond chip design and simulation to what has been now called robotics and maybe broader system simulations, or not necessarily?
Absolutely. So let me first tell you about the world of automotive, how it's going to transform, right? So when you look at a software-defined vehicle, so a car like a Tesla car, you have a maybe 10, 20, 100 million lines of code that goes in the car to make it an autonomous electric vehicle. Now, that autonomous software runs on an ECU. It's a silicon chip. The silicon chip is being designed by a Synopsys tool, like a Synopsys EDA tool like Fusion Compiler. But the ECU designer, the chip company, has not yet designed the chip. So what do you do? With our Synopsys tools, it is possible to do an emulation of that chip on a box that we have called ZAPs, ZIBU and HAPS, right? You can emulate the software. So you write the software, it will run on the chip as if it existed. So even before the chip has been designed and fabricated, we can allow the software developers in an OEM to start developing the software. Then what you do is you build this thing called electronic digital twin, which is saying we have platforms like Silver and Virtualizer, which allows you to do what is called model in the loop and so on. So it's allowing the OEMs and the tier one companies to kind of work on the design of the car. But then the actual car has brakes and steering and so on. Those are mechanical parts, right? So those were being designed by the Ansys tools. But now imagine these physics of those different fluids and electromagnetics and the crash, all of that is modeled through Ansys tools. And you can use what is called reduced order models to plug into the electronic digital twin and build this incredible joint solutions, right, which will transform the automotive industry. Same thing will happen to the aerospace industry. I was talking to the CTO at Boeing, and he was saying this is exactly what the vision is. And you mentioned robotics, right? The whole world of robotics and physical AI. These robots do things, right? And they're moving your action, and you can train a robot with using a robot language, or you can train a robot by saying, here is a bottle, here is how I pick up the bottle, right? And so you can take an image, a video of Prith picking up the bottle and learn this is how he keeps the bottle back. Now, these things, robots used to be trained with video. Now with the Ansys simulation, or now the Synopsys simulation, you can model all the physics, the bending of the arms and so on, and creating the synthetic data. You can, in the world of physical AI, you can actually train those robots and so on. So the world of physical AI will be completely transformed and enabled through Synopsys.
It sounds science fiction, at least to me. And you mentioned the digital twin. How significant you think this technology is going to be for accelerating software validation before the hardware actually exists, either in automotive or even in other industries? I think in terms of the money that it's going to save, it's going to be groundbreaking.
It is. Actually, digital twins have been used in different industries, in automotive, in aerospace, in energy. In fact, we are just having the NASA send out the Artemis aircraft, right, to go to the moon. The first application of digital twin was proposed by NASA when the Apollo 13, the accident happened. So there was these astronauts, they were circling the moon and they were trying to bring them back, right? So essentially NASA created a digital twin model of that airship. And from Houston, they said, what if I did this? What if I did this? And essentially using that digital twin model, which is a simulation model, trying to emulate what is happening in the real world, they are able to bring down those Apollo astronauts. So that's what Michael Greaves from NASA actually coined the term digital twin. Now, this has been used in industries by GE for their aircraft engine digital twinning, or in automotive by BMW and Mercedes and so on, right, for digital twinning, or in energy by Siemens for doing all those wind farms. Every industry, Medtronic for doing all the digital twins of pacemakers. So we have been helping, Synopsys has been helping all our customers in all these different industries to build digital twins. And so the digital twin that we are helping with is, before the product is designed, can you build a twin, including the hardware and software combination, and do all kinds of what if scenarios, what will happen if this happens and so on, and it accelerates the design process. It used to be the case that a new car would be designed every maybe 7 years. We are now trying to accelerate the design process to, can you do it in 2 years? Can I do it in 1 year? And the complexity of innovation is increasing, right? You now have 100 billion transistors on a chip. You can have 1 trillion transistors on a chip. So as the complexity of these systems increases and the time to market reduces, this combination is enabled by the technology from Synopsys, which is the digital twinning technology, the AI-enabled silicon design, software-enabled technology of intelligent products. And in that workflow, there was a way that engineers in these different industries like aerospace, automotive were doing that stuff with human engineering. Synopsys is revolutionizing the process of designing intelligent products with what we call re-engineering engineering, using a concept of agent engineers, right? So in the past, a human engineer, you are saying, okay, I want to design an airplane. How do I do that, right? I do these things. I change the CAD, computer design of this product. Oh, I do a simulation. I go back and forth, back and forth. In the world that we are working on, right, with agent engineers, we'll have different agents. They will have a creative agents that will help you write an RTL, a register transfer level design. It will help write the test bench to verify. So all the tasks that were being done by a human will be done by these agent engineers, but these multi-agent engineers will all collaborate, work together with the direction of a human engineer. So the human engineers will become super engineers. It's that transformation of the workflow called re-engineering engineering that I am super excited about.
It's a great segue for my next question, because Synopsys is celebrating 40th anniversary this December. But How does the company vision to re-engineer and engineering prepare the company for the next 40 years of innovation?
In academia, I used to work in the field of electronic design automation. So I actually saw Synopsys get founded. I knew the founder, R.G. Just, from the time I used to meet him in DAC conference and so I saw how Synopsys got created as a leading company, design sort of enabling, creating the technology of RTL synthesis that transformed the world of chip design and synthesis. Something that customers used to do with custom design that Synopsys brought to market. But now, as I said, people are moving from chips to systems, these intelligent products like vehicles and so on. But as I said, the complexity of these vehicles and aeroplanes and so on is so hard, right? The pace of innovation, instead of coming up with a new product every 4 years or 7 years, is now a year, and the complexity is increasing. It is so complex that the world would need 100 million engineers, 1,000 billion engineers, and we are not graduating that many engineers in the process. So therefore, Synopsys in its 40th year has come up with this new term called re-engineering engineering, which is enabling our customers to build a lot more complicated products much faster than could have been imagined.
We talk a lot about Synopsys innovation, and of course now everyone talks also about AI. How Synopsys has been embedding AI across design workflows? Do you see AI primarily improving productivity, maybe enabling a new design exploration, or even driving entirely new architecture?
That's a great question. And let me break it up into chunks. So Synopsys is a software company, right? And as you know, the world of software design is getting completely transformed with tools such as Cursor and Claude and Copilot. So you have a human designer, human software engineer who's writing a code, is giving a specification. So I need to write a Fusion compiler, right? And the human designer would have taken maybe 3 months to write it. Working with a Cursor, with a Claude, with a Gemini, with a Copilot, it is improving the productivity of the software engineer like incredible, right? We are seeing so much improvements that our software engineers are using all these tools, right, to help write code better, faster, and can verify easily. So that's the first thing, right? Improving productivity. Secondly, making our tools better. Many of the tools that we have, they're optimization tools. They do things like placement of 1,000,000 cells on a chip in the most optimal way, or routing 1,000,000,000 wires on a chip in the most optimal way. Each of these problems are very hard in the world of computer scientists, called NP hard problems, meaning they are not polynomial, right? So we come up with heuristics, simple ways. Oh, I cannot solve it optimally, so let me give you a heuristic that will kind of give you as good a solution as possible. It turns out with AI, you can actually do a much better search. So we have got AI embedded in every one of our tools with, say, from placement, routing, synthesis, and so on. So that's the first step. Then what we did is we took entire tools like placement tool or routing tools, and we used reinforcement learning. So I have children, and you teach your child to do certain things, right? So you're saying, I am about to ride a bike, and if you are falling on the right-hand side, then you make a left and then you balance. But if you go on the right, then you fall off. So when you fall off the bike, that's a penalty function. And when you are balancing, you get a reward function. So in AI, there's this concept called reinforcement learning, where a combination of reward functions when you do positive actions and penalty functions when you do negative actions, it helps train the AI to do smart things, right? So essentially, you're giving a bunch of actions and it learns. So we have applied that in a set of tools called Design Space Exploration, DSO. And DSO.ai was brought to our customers in 2017, and we found incredible advantages in the power performance area of the designs, right? We got maybe 20% improvement. So that's where you got started. Then we say, hey, it works for digital design. Let's try it for analog design. So we did it on ASO.ai, and we got similar advantages. Then we say, hey, we are doing things called in the testing world. Let's call TSO.ai. So we did TSO.ai. Then we said, can I apply it to verification? So we applied called VSO.ai. So the first round was AI embedded in the tools. Second one, this reinforcement learning on DSO, VSO, ASO, etc. Then we said, hey, these things are doing reinforcement learning to improve optimization. Can I now have agents that will help do the work. And that's what we've just got started on the agentic workflow. So we've got, say, test bench agents or verification agents or these corrective agents. And then now we are on this journey of this multi-agent workflow, which will be completely automated. And the vision that our CEO Sachin has shared at Converge is just like in the autonomous world of driving, you have level 1 autonomy, which is assisting a customer in doing cruise control, automatic driving, or in self-parking, all the way to these Waymo cars doing fully autonomous driving in the streets of San Francisco. In the future, Synopsys re-engineered engineering multi-agent workflows will help autonomous design of chips and systems.
And with AI now entering the chip design, what do you think become the bottleneck? Is it compute verification or the human creativity part?
It is a combination of all of it, right? Because in the world of AI, you have these large models with 1.9 trillion parameters and so on, right? So there's a lot of training that you have to do. These trainings are done on the obviously large clouds, and then you have to do the inferencing, right? These models that are being used as part of the tools themselves. So these things require massive, especially when you're in the world of simulation, right? These things require massive compute things like the GPUs and so on. So at NVIDIA's GTC conference, Jensen kind of highlighted the work, the collaboration that is going on between NVIDIA and Synopsys, right? I mean, I'm sure you know that NVIDIA invested $2 billion on Synopsys. Why? Because we are using our Synopsys software to leverage the GPUs, right, to make them go faster, and leveraging AI to make it go faster. And these things are running on the NVIDIA Omniverse, right, to help our customers build much more better products. The concept of physical AI that Jensen talks about is being enabled by Synopsys. So that is the opportunity. But of course, these are limited by the power of the GPUs, but the GPUs are getting faster and faster. You are seeing larger and larger systems, but the only limit is human creativity, right? We have tools like Geom AI that will help create the geometries, but then so the question is, what does the human do? Well, the human actually takes a higher level job, right? They will coordinate these agents to do even more creative designs of those intelligent products.
You mentioned NVIDIA. We actually hosted about a year ago Mike Kagan, the CTO of NVIDIA. And when we asked him what is the next thing for NVIDIA, he mentioned that it's going to be probably the simulation of the physics. So it's interesting to see this combination with Synopsys now. And I do have one last question, Prith, before I pass the mic to Amado. So many hyperscalers now designing their own silicon, or at least say they're going to do it in the near future. But how this new trend impact the importance of neutral platforms like Synopsys?
The thing is that the Synopsys tools are used in all forms of chip design. They are used in the design of chips at NVIDIA, right? And so obviously, and AMD, the new GPUs and the CPUs from Intel and ARM. So the normal compute platforms use the Synopsys tools to design these things. But then these GPUs are being used to build those AI models, right? Where do the AI models run? They run on the cloud. But then if you look at the cloud providers, they are providing, first of all, different levels of service. The infrastructure is a service where the customers are asking for, I want to run it on a AMD GPU or a NVIDIA GPU, they'll provide those GPUs. But for AWS to provide on their Bedrock system for AI, where it is an AI model that is powered by Anthropic, they don't care which CPUs they will run. So they want to run it in the most optimal, efficient way. So therefore, AWS is creating the Trainium chips, inference chips, right? And so each of the cloud hyperscalers are designing their own chips to get the most optimal design at the trying to optimize the speed and the energy and power consumption and so on. It is good for Synopsys because Synopsys, suppose the whole world was only using NVIDIA and AMD's GPUs, then we would be only selling our software to these providers. Now we have all these interesting companies who want to build their CPU, GPU, TPUs from Google and then NPUs. So it literally allows Synopsys to provide our integrated solutions for chips to systems to a broader range of customers.
This seems like a new world of compute altogether, and I guess with quantum, it's going to be only much more than this. And Armando is going to ask a couple of questions about it in a bit. But Prith, thank you so much for answering all of my questions. Armando, without
Thank you.
further ado, the floor is yours.
Prith, on your last note, you just brought up serving a broader range of customers, and Synopsys already serves a broad range of customers, from telecom services, aerospace, healthcare, even university research. You even brought up NVIDIA, so it's very impressive. Looking at that developmental process, time to market, the semiconductor industry is known for a long time to market. Tools with these new simulation tools, do you see the possibility of delivering client solutions faster than ever before?
Absolutely. This is exactly when I was talking to Yossi, I kind of mentioned that in the past, each of these industries used to have design a new product, like in a car industry, automotive industry, a new car platform came in maybe every 6 years. Now it's happening every 2 years. People are trying to do it in 1 year. Same thing for chips, right? A new chip from design, from concept to actual fab and coming out, it took about 3 years. NVIDIA is now talking about getting a new chip from start to finish in a year. And these chips used to have 1 million transistors, 10 billion transistors, 100 million, a billion, 10 billion, 100 billion. Now they'll have 1 trillion transistors. Imagine designing 1 trillion transistor chip in a year. How complex is that? That is the complexity I was talking about to Yossi, right? Why Synopsys came up with this new way of re-engineering engineering in our 40th year.
And that's fantastic. Really quick on that note, Prith, about the possibilities going from 6 years to 8 years down to 2 years. When it comes to med tech, software, what new possibilities do you think that higher speed will bring to us in terms of everyday life?
That is such a great question because you have hit on a topic I'm very passionate about, healthcare, right? So imagine you could have, suppose I have a heart problem, right? I have arrhythmia, which is an irregular heartbeat. Now the solution to that irregular heartbeat is to use a pacemaker from companies like Edwards Lifesciences or Medtronic. But then each human is different, right? Yossi's heart is different from Prith's heart. Prith's heart is different from Armando's heart, and so on. So what you would like to do is to take Prith and do an MRI scan on Prith's heart. Now, it is possible today with the Synopsys technologies that we have, you take that MRI image using our simpler tool from Synopsys, you could take that 3D image and generate the meshing and generate the simulation, the CAE software, right, with using LS-DYNA to simulate my heart. Now, a doctor can say, okay, here is Prith, he has arrhythmia, here's this thing, I'm about to do a surgery, I'm trying to make a case here, right? Now, which kind of a Medtronic pacemaker should I use? I should use small, medium, large. Okay, I can do a simulation. If I did this one, it would work this way. Where should I plant it? I should plant it this way. So it can create a digital twin of that human heart with an accuracy that you couldn't do in the past, because you can now take the heart, you can do patient-specific operation and workflows which you could not do in the past. So it's going to completely transform healthcare. And when I was CTO at Ansys, I had my teams working on those as a prototype, and now these are being sort of worked into products at Synopsys. Just an incredible journey.
Absolutely. That's fantastic, especially with the aging workforce. We need people healthier longer. So I think that's fantastic. Touching on emerging technology, staying on that, looking at quantum. Now everyone is talking about AI, but another groundbreaking technology is quantum that holds immense potential impact. How important is quantum relevant to Synopsys?
It is super relevant in the long run. People are working on quantum technologies. We are partnered with many of the quantum companies, with IBM, IonQ, Quantinuum, etc. So many of them we are working with. What's the key thing about a quantum? On a digital computer, you have a bit which can go 0 or 1. So two states. In a quantum qubit, it can be 0 and 1 at the same time. So what advantage does it get? Well, if you have a single bit, it is representing 0 and 1 at the same time. If you have 2 bits, it is representing 0, 0, 0, 1, 1, 0, 1, 1 at the same time. If you have 10 qubits, it represents 2 to the power 10, which is 1024 states at the same time. If you have 20 qubits, that's a million states. If you have 30 qubits, that's a billion states. 40 qubits, a trillion states. So imagine if you can do 1 trillion things at the same time with 40 qubits, what kind of speed up can you get? So while I was at Ansys, we were looking at using quantum algorithms to speed up our solvers by these kind of times, right? Using lattice Boltzmann methods and Hamiltonian simulations and so on. In the world of Synopsys, we do optimization problems like cell placement problem, graph partitioning problem, routing problem. These are fundamentally hard problems called NP hard problems. These hard problems can be solved with quantum, right, in the future. So that's one thing, using quantum to accelerate our solvers and tools. The other thing is Synopsys is in the tool business, right? So Synopsys tools can be used to build quantum computers. So when a quantum computing company is trying to do a qubit using, say, superconducting qubits or photonic qubits or trapped ions, that is physics. That physics is modeled by Synopsys tools using tools like Quantum ATK and HFSS and RaptorQ. So we have two ways of benefiting our customers with quantum, using the Synopsys tools to help build quantum computers and using quantum computers to accelerate our Synopsys tools in the future, just like it is being accelerated on GPUs.
And that potential optionality is very, very exciting. Looking at another venture, you recently talked about partnership between Inattera and Synopsys. Can you tell us more about how you view the future of neuromorphic?
We talked about the technology of machine learning, and there's a technology of quantum, and there's a field of called sort of quantum machine learning that is going on. And now neuromorphic computing is a sub-field. Essentially, it's taking a relationship of how the neurons in the brain work. The neurons in the brain, they don't consume power like GPUs. GPUs are huge powerhouse, but a brain, they do much more complicated things. But look, they don't spend as much as power. So neuromorphic computing is saying, how do neurons in the brain actually work, and try to do it with low power chips. So this company Inattera that we have partnered with has come up with this neuromorphic chip way of solving these kind of AI problems, but using very, very, very low power. And so this technology will be extremely useful in the edge, right? So you do large training of these models on the cloud, but you do inferencing at the edge. But today, the edge inferencing is done by sort of the traditional computers, right? And they require a lot of energy. Neuromorphic computing technologies like Inattera will allow you to do that AI inferencing at the edge, but at 100th, 1000th the power and in real time.
Very, very impressive. Now, touching more on Prith, from your time in academia and engineering leadership, what's a simulation insight that most people outside Synopsys would be surprised to learn?
They'll be surprised to learn about how accurate Synopsys Ansys simulation can get, right? So when you are designing a car, right, you are saying, I'm designing a car, and this car is going on a icy road. If I were to, you have done this pumping of the brakes and so on, and then, oh my God, it does crash. And if the crash happens, what will happen? The accuracy with in the past, people used to do this crash testing with actual physical testing. They put a dummy in the car, put a car and drove it at 60 miles per hour on an icy road and banged it and see, did the dummy survive or not, right? Today with LS-DYNA simulation, you can do the entire crash so accurately without any hardware at all. So something that would take you $2 million to build that hardware prototype, you can do a virtual crash simulation. Or say a Boeing or Airbus doing an airplane design. You design the airplane wing, you put it in a wind tunnel, and you test it to see if the wing shape will lift or not. You don't have to do that wind tunnel testing anymore. It's done through virtual wind tunnels. So this is the power of simulation that your customers, your audience should be aware of. It's just incredibly accurate, and it's transforming the way you don't have to do any physical prototyping in the future world of intelligent product.
I think that'd be the question. Is it reliable? And according to you, it is. So that'd be much cheaper. We can do much more simulations, which would be faster. So I think that's great that we don't need a personal dummy anymore.
That's exactly
So,
it.
and touching more on that, personally, advice for builders looking at innovations to the future. What advice would you give builders navigating today's environment?
So what I would advise is yesterday's technology is you sort of come up with a requirement of a car or an airplane or a pacemaker, right? And then there's a thing called a V cycle where you essentially take that system level requirement, you break it down to subsystems, then components, and you do that detailed component level at a CAD level, CA simulation, and you do the verification on the right hand side. It's called a V cycle. That's the old way. The new way is powered by AI, powered by simulation. It is what we call shift left. Everything done through simulation, so you don't have to do any physical prototyping. This is the world of future. So I would ask your audience to learn about the power of simulation and the incredible opportunity. You can do thousands of airplane designs, tens of thousands of automotive designs on the computer, and you can pick the right one, and you could actually do customized design. And the field of manufacturing is going towards customized design. So you design that most optimal car, 5-wheel car, right? Peculiar thing with a blue, orange, whatever stuff customized to you. And this one thing will come because you will design it on the CAD. That CAD will be uploaded to the CAM tool. That robotic thing will manufacture that customized car for you. This is the future.
It's an exciting future. Now, on top of the advice that you give to aspiring entrepreneurs and builders, advice that you've gotten, mentorship, who has had the biggest impact on you as a mentor? It might be more than one person, and why?
Actually, the most important mentor was my brother, who is a Sanjay Banerjee, he and I were very close. I literally followed his career. We both did our schooling from India, from Don Bosco School. We both went to IIT Kharagpur. We both did our PhD from University of Illinois. We both went to academia. I went to University of Illinois. He went to UT Austin. Every Sunday, I have a 1 hour chat with him. This is what I'm doing. This is what I'm struggling with. And he has been my guiding force and every step of the way. So he is my mentor.
That's consistency. Keeps you grounded, and I'm sure you also help him out as well.
Absolutely.
Absolutely. So my last question for you, Prith, before I ping it back to Yossi. Speaking about mentorship and people you look up to, you actually wrote a successful book called The Innovation Factory. What led you to write this book, and can you tell the audience what it's about?
It was this kind of podcast that you are doing. Because of my career in academia, startups, and the corporate world, podcasters like you reached out to me, Prith, talk about innovation, right? What have you seen? And I kept doing this. The third podcaster said, Prith, you have so much to offer. You should write a book. And so the book Innovation Factory, the key thesis of the book is large companies like ABB, Schneider, HP, Synopsys, they do the Horizon 1 innovation, the incremental innovation, right? We have a product called Fusion Compiler. What feature should be in a Fusion Compiler? They nail it. Every large company nails the Horizon 1 innovation. They also do a good job in Horizon 2, the next step. I have some products on the cloud or on premise, I want to go to the cloud. That also they know. But to do a truly disruptive innovation is hard. And what I say is look to universities, look to startups, and by combining the organic innovation that you have within the company with this partnership with startups and academia, that is the way to do disruptive innovation. This is something that Henry Chisborough at Berkeley has talked about in his concept of open innovation. This is what I write in my book.
No, that's what I'd love to hear. I'm actually an aspiring author myself, so getting to learn from one, also a builder, was music to my ears. Prith, thank you so much for the great answers. Yossi, back to you.
So, Prith, I do have actually two last questions to ask you. Two of the most interesting ones, for me at least. If you could have a coffee with anyone, alive or historical, who would it be and why? And then I will ask the second question. So.
Well, it would be with former President Barack Obama. I thought he was an incredible leader, and his style of leading is actually something I try to emulate in my own life. He surrounded himself with the smartest people, and I have seen him do so many interviews on CNN and others, but I would love to have a chance to talk one-on-one with Barack Obama.
A Promised Land. I recommend that book.
Yes, I have read it. It is a
I'm
great book.
sure you have. Yeah.
Fantastic.
Two professors, two academics.
Yes, you can. And one of your and what is your favorite movie and why?
It's actually the movie Gandhi, which is about this individual, Mahatma Gandhi, whose life, and it is actually a biographic movie. The actor was Ben Kingsley, and it won, I think, 8 or 10 Academy Awards. But I liked Gandhi. Well, I am of Indian origin, so I knew the Indian history, right? But the way it was portrayed and the journey of a young lawyer in South Africa, and he goes to India and trying to lead the independence motion with the Salt March and so on, driving the whole non-violent movement, which is now obviously Martin Luther King and others kind of emulated. But it was such a wonderful movie. It's a true portrayal, and it showed how leadership can be done. So that's why I loved it, and I have watched it so many times.
So 2 visionary leaders out there. So Prith, thank you so much for joining us. It's really been a joy to learn from all of your experience. So thank you so much. And for
Thank you.
everybody else, absolutely. And for everybody else in the audience, so stay tuned. We have other amazing episodes to show you. We just hosted earlier today the CEO and founder of GenSpark, also the president of Cisco, going to join us as well tomorrow. It's going to be interesting. So stay tuned.